Hi everyone. In this given problem statement, you have to find the medium from a data stream. A medium is the middle value of a ordered integer list. If the size of the list is even, there is no middle value, and the medium is the mean of two middle values. So basically, right, in case our value or the our size of our array that we are going to form is odd, then the medium is going to be the middle value. In case it is even, then the middle is going to be two middle values divided by 2 to find the medium. But this problem is of one of the hardest problem. Okay. So if we are going to get the numbers like 1, 2, 3, we can form the array 1, 2, 3, and we can find the medium. But the problem out here is going to be that it will not pass the test cases. We have to find something of a genius, and that's why it's a pretty hard problem, because to find a solution of this, right, it is not very intuitive, right? So one thing that would come to your mind is that because every time we are going to add a value to our array, right, we have to sort it, right? Can we use a heap queue? So to use an heap queue, right, so I can form a heap, and then I can add the values 1, 2, 3 pins, and whenever I add an element, it is the array is going to get sorted. So to add an element, right, it is going to take log n, and let's say there are k elements, it is going to take k log n. But now a question would be, right, how will I find the middle element? So that would be another problem. So to solve it, right, we have to create two heap queues. So one would be a small heap, and another would be large. So basic idea is that let's say you have values of 3, 4, 1, 9, 10. Okay. So whenever we get an element, right, first thing that we're going to do, right, we are going to add that value to our small heap queue. But this is going to get formed with max heap, and this is going to get formed by min heap, and it is an intuitively problematic thing, but the basic idea is that let's say we got 1, or let's say we got 3 in this. I will make you explain right how to do this. Now we got 4, so we are going to add the 4 value, but a question would come, right, so you have to also maintain that the both of their sizes, right, should be same or at least one greater. Now the size is 2 and it is 1. So what we are going to do, right, we are going to pop out the biggest element from here and add it to our large heap queue. Then again we are going to get 1, so we are going to add 1, but it is going to get automatically sorted, so it would be 1, 3, and it is 4 right now. Then we are getting 9. So once we get 9, again, right, the value is 3 and this is 1, so it is not in balance, right? So we are going to pop out. So the basic idea is, remember, right, the small one, the length of the small one is going to be balanced if its value is less than, or let's say it is balanced, right? I can say it if both of the length are same, or at least one value is increasing, and this is why it is increasing, right? So the basic idea is that in case, right, our array is odd, right, then a small or a big, at least one of them is going to contain an extra element, so both of them will not have the same number of element. But in case it's an even, right, then both of them are going to contain the same number of values. So I'm going to pop out 9 and add the 9 out here. Then we are going to get 10. So we can add 10 here. But again, there is one more condition to check, right? So we're going to check, is the current 10, is it less than equal to our our large heap queue? In case it's not, right, then we are going to pop it out and add it to out here. So now the value that is getting formed, right, it's 1 3 4 9 and 10. So out here, right, the one which is containing the large element, right, because it's an odd one, so our medium is going to be 4. So our one question, right, in Python you cannot directly form max heap. So in order to do it, right, so when you're going to add the elements, right, so elements are added like -1 -3 in this order. So if you look into it, right, this is intuitively kind of correct, but so if I add these values, right, so it would be -3 -1. So in this way it is going to get formed. So I'm going, when I'm going to write the Python code, right, I'm going to explain you, right. So whenever you're going to form a max heap, right, so the basic is that when you're going to push that element, right, convert it to negative so that the structure is kind of maintained. So that's the idea. So that would be the reason. So I hope you're able to understand, right, why we require two values. So in this case, right, adding a value to our heap queue, right, would take log n. Removing an element is going to take log n. And if there are k elements, right, it would be k log n. So that would be the kind of time complexity for solving it. But there are a few more caveats out here. So one is that we have to always keep the minimum small heap queue and large heap queue always, right, there. Both of them, right, should not be, means both of them should be less than, means should be, ideally should be equal in case, or in case if they are not balanced, right, the difference should be at least 1, not more than that. In case it's more, then we're going to pop an element from any one of them which is having the higher number of values and add it to the other one. That is one thing. The second is that once we are adding an element to our main heap queue, right, or our small heap queue, after adding it, right, we are going to check the value that we have added, right, is it smaller, means is it greater than the large heap first value. In case if it's greater than the large heap first value, right, then we are going to pop that element out and add it to large heap queue. So that is one thing. And obviously you're going to check for the balanced condition for both small and large. And another thing, right, when you're going to return the result, so in case, let's say small is greater, like the, in case both of them are unbalanced, right, then what we are going to do, whichever is having the larger element, right, that is going to contain the medium element. So we are going to pop that element out and return it. So in case the smaller one is containing the larger, let's say more, means one element greater, right, then we're going to pop from the smaller one. In case the larger one is containing the bigger element, then we're going to pop the larger one and return it. In case both of them are containing the same number of elements, right, means both len small equal to length of, let's say, big one, then I can say return small the first element plus big of the first element. So that's the idea how it is going to work out. So, and how it is going to work, right, let's say whenever you're using a negative number, right, so the idea is that when you're removing the first element, right, or popping out the first element, so it is like why we should be adding negative numbers, right. So let's say if I'm adding these values as 1 and 3, right, it is not the correct way because we are forming the max heap out here. So what we are going to do, right, we are going to add -3 and then -1. Okay, even though it looks for the heap understanding, they will think, right, the -3 is smaller and -1 is greater, so it is basically a main heap. But when you pop that element out, right, you know you have added that element as -3, so you can then, once you pop it out, so -3, once I pop it out in this small 0, right, I will just add a -1 or multiply it by -1 to get the positive value. And if we look into the code, right, so it would be clearly written, right, somewhere the other, all you need to check it, right, that all the values in this case, right, all the values that are getting added, right, all of them are in positive, so we can form max heap from here. Now a lot of understanding is required, and a good understanding of heap queue is required to come up with the solution. Once that is done, now let us jump to the Python solution where we're going to explore and understand and code this problem in detail. The first thing that we need to do, right, we need to create or import our heap queue. So import heap queue, and then we have to create or initialize in our constructor, right, our self dot small, which is going to contain all the small elements of the array, and self dot big, which is going to contain all the bigger elements. At the same time, right, to improve our complexity, we are going to also create a counter. So self dot count small is going to be 0, and self dot count big is going to be 0, to keep a track of the number of elements that is present in the smaller array and the bigger array. Now once that is done, right, here we are going to add the num to our smaller one, because initially, right, by default we are always going to add the num to the smaller one. So I can say heap queue dot heap push, and here I have to pass in self dot small. And as I remember, as I told you, right, here we are going to form the max heap, so we will always have to pass in the value with negative, so it would be nums or num. Once that is done, right, I will increment the small counter, so self dot count small by 1. Now the next thing is that we will have to check whether the current small that is present at the top, right, in case it's greater than the one that is present in the first element that is present in the big one. Okay, so reason being that the smaller one will always contain all the elements which are smaller, and the big array or the big heap queue, right, is always going to contain the elements which are larger. In case the smaller one contain any element which is greater than the first element of the big one, then we just have to pop it out and add it to the big. So I can say if self dot small, so our small array exists, and self dot big and self dot small, the first element, if it's greater than self dot big, the first element, then what we are going to do, we are going to add it. I'm going to create a temporary variable, and here I can say heap queue dot heap pop, and it would be self dot small, And because we are going to get the element in negative form, right, we will always have to make it, in order to make it positive, we have to add a minus. And we will decrement our counter of self dot count small by minus 1. Once that is done, we will have to add this element to our bigger one. So heap q dot heap push self dot big, and we will pass in the value that we popped out, and we will increment our self dot count big by plus equal to 1. So once you have done that, right, you will also have to maintain the balance. So if self dot count small is greater than self dot count big plus 1. So as I have told you, right, the difference between both of them should always be at least 1, or ideally should be equal, but in case it's an odd, right, the array or the number of elements is odd, so at least the difference should be at least 1. So in case, right, if the value is greater, right, then what I'm going to do, again I'm going to call val equal to minus heap q dot heap pop, and here I'm going to pass in self dot small, and I'm going to call self dot count small minus equal to 1, and I'm going to push that element. So heap q dot heap push self dot big with our val and self dot count big plus 1. There could be also one condition, if self dot count big, so the larger array, right, is containing more elements, then we have to pop and we have to add that to our smaller one. So self dot count small plus 1, then in that case the val equal to heap q dot heap pop self dot big and self dot count big minus equal to 1. We have to add that, so heap q dot heap push self dot small, and whenever you're adding it, right, because it's going to be a max heap, right, we have to always add by converting the number to negative. So it would be minus val, and we're going to increment self dot count small by 1. Once that is done, right, we have to find the medium. So here also we are going to check with if self dot count big, if it's greater than self dot count small, then we can say the value is in the bigger one. So bigger one is containing, because in this case, right, it's an odd, so the value would be in the bigger heap q or the larger heap q. So we are going to return self dot big of 0, elif self dot count small greater than self dot count big, then the element is in smaller one, so I'm going to say return self dot small of 0. And also one more thing, right, because here all the numbers are negative, right, when you're storing it into the heap queue, into a max heap queue, so whenever we're going to return it, we have to again convert it, so it would be minus returning. And else if both of them are same, right, then it's an even array, so it would be return self dot big 0 plus, and here, right, we have to again convert it back, the whatever value that we get from the smaller one, self dot small 0, and it would be divided by 2. And here if you look into it, right, we should be giving the floating point value, so no need to do double division. So let me run it. I hope it should work unless there are some spelling errors. So let me check. Yeah, I forgot one thing. It would be minus self. This is something tricky, right? We have to take care of it. As you could see, because you always have to convert when creating a max heap. So as you could see, it ran successfully, and let me show you the entire code. It is a little bit bigger one, and it is, to be honest, it's not very intuitive. I also was able to understand the solution at one go, but if you understand heap queue, right, I think if you solve these type of problems enough, I'm pretty sure you'd be able to have a understanding of it. So this is the entire problem. Let me submit the code. As you could see, the code got submitted successfully. It is beating 60.21, and the time complexity, right, it would be almost like, if you know, right, to add an element to a heap, right, it is log n, and if there are k elements, right, it would be k log n. But also, right, again you have to, let's say you have to pop an element out from a heap queue, and then again have to add that element, so it is going to take time. So but it would be in the range of k log n, in that range only. I'm not going to give you the entire step by step, the accurate time complexity, but giving an average estimation. So that's all for this video. See you in the next one.